so let me start recording again. It'll just be in two pieces, y'all, but I'll send the video out later. Yes, let's definitely go over 19 and 10. So let me come back up here. Where's 19? It's right here. Okay. Let me do a little copy and paste. Sorry about those of you at home. I just didn't hear I didn't hear you guys ask the question. I didn't hear it. Usually I get a little bump, a little noise. I just didn't hear it. Okay, so write the number in complex form where theta is between 0 and 2 pi. Write your answer, simplified fraction necessary, give an exact answer. Okay, so let's come back here, y'all. First thing I'm going to do, I'm going to bust out my numbers for complex numbers in polar form, right? So here we go. Complex numbers in polar form. The way we're going to write them is like this. Z equals r cosine theta plus I sine theta. What is r? R is the modulus, the square root of a squared plus b squared. So let's first find the value of r. So it's going to be 7 squared plus negative 7 square root of 3 squared. So 7 squared is 49. Plus, when we square negative 7, that's still a 49. The square and the square root would cancel each other out. That's just going to give me a 3. So 49 plus, let's see, whatever 49 times 3 is, that should actually be 157. And then, let me see, I think it's 157, 147, oops. Okay, so 147 plus another 49 is 196. And the square root of 196 is 14. Okay, so we came up with our r already. We know that r is 14. Okay, I'm going to come back to my formula sheet, y'all. And let's see. We're going to write z equals r cosine theta, I sine theta. And how do we find our theta? It's going to be the tangent of b over a. Okay, oops. So the way I'm going to find my angle is the tangent of theta is equal to b over a. So the tangent of my angle is b, which is a negative 7 square root of 3 over a, which is 7. So this is going to cancel with that. That is a negative square root of 3. Okay. So theta is the tangent inverse of the negative square root of 3. So y'all, first thing I'm going to do, I'm going to come back to my trig functions right here. And we said the tangent is equal to the negative square root of 3. So I want you to look at that chart here, y'all. Let me see if I can open this in here we go. Okay, so look, I got a value right here. So it's either 2 pi over 3, or I have another one over here, which is 5 pi over 3. So the way you're going to figure out which one we're going to use, I want you to look at the values that we had. We had 7 and a negative 7 square root of 3 with an I. What quadrant would that be in? Where the first coordinate is positive and the second one is negative. Would we be in quadrant 1, 2, 3, or 4? We'd be in quadrant 4, right? Because my first value, my A is positive, but my Y value or my B value is negative. We'd be in quadrant 4, right? So when I come back and look at this part right here, this is the one that's in quadrant 4. So I'm going to use 5 pi over 3. Does that make sense? That's how I'm able to kind of figure out which part I'm going to use. So I'm going to say that our theta is 5 pi over 3. And the only reason I'm using the radian form, y'all, is because it's telling me right here in the problem, give it with where theta is between 0 and 2 pi. So that's why I'm using the 5 pi over 3. If it said 0 to 360 degrees, I would use the 300 or whatever value it was, okay? So look, we're going to write this now. We're going to say z equals r, which is 14, and then I'm going to write cosine of 5 pi over 3 plus I sine 5 pi over 3, right? And so I'm going to come back to my original problem, which was right here. And we're going to put 14 parentheses cosine of 5 pi over 3 plus I sine of 5 pi over 3, close it, check it, and let's see, did it work? Boom, it worked. Okay. And then we can do the second one. We'll do it the same way. Okay, let me copy this here, and let me come back over here, paste it. Okay. There you go. That's exactly right. So y'all, if you, those of you at home, if you didn't hear Jennifer, she said, look, my R is going to be the same thing. That's a negative 7 squared plus 7 squared to 3 squared. All this business is still come out to be 14. And then when we do the tangent of our angle, it's the 7 squared root of 3 divided by a negative 7, which is still negative square root of 3. But now, when I look at my chart, now we're actually in the second quadrant, right? Because when I come back over here, my A is negative and my B is positive. So we're now in quadrant 2. So our theta here was, I think it was 2 pi over 3. Yeah, our theta here is going to be 2 pi over 3, right? So that's exactly right. So my complex number is going to look like this: 14 cosine of 2 pi over 3 plus I sine of 2 pi over 3. And that's all you're doing. Excellent. Good. So 14 parentheses cosine of fraction 2 pi over 3 plus I sine fraction 2 pi over 3. Close those parentheses. Tickety check. And we got it. So Thomas, I hope that works for number 19. And Luciano, I think you said you had number 10. Okay, so let's take a look at number 10 here, y'all. Again, we'll draw a picture, or they already have a picture, and let's see if we can't figure this thing out. Okay. And I know somebody asked this one day when we were in class, right? What was it? And this was the one where it was just like this, the sides, right? It would kind of, yeah, that's all it was. Okay, so let's take a look here, y'all. It says a helicopter is on path directly overhead line AB when it's simultaneously observed from locations A and B separated by 700 feet. The angle of elevation from A is 40 degrees 35 minutes, and the angle of elevation from B is 34 degrees 16 minutes. Okay, so I'm going to say this angle here. Let me go this way. This angle B is 34 degrees 16 minutes. Okay, and we're trying to figure out the distance. We're trying to figure out, say, this here. This would be little b, and this would be little a, right? Okay, so let's call this angle right here big angle C. Okay, so if I were to take these two angles and add them together and subtract it from 180, we could find the big angle for C, right? So first thing I'm going to do is, here's my calculator. I'm going to think of this as 40, oops, turn it on first. 40, and let's see, what is 35 divided by 60? Actually, let me do it like that. Oops. 35 over 60 is that, so plus 40, there's that angle. Put 16 divided by 60. Oh, point, okay, so 34. So the first angle is going to be something like 40.58. I'll go to 4 decimal places, plus 34.2123 decimal places, okay? And so 180 minus that, oops, is 105.15 degrees. Okay, so this is 105.15 degrees. Okay, so now that we have that, say we want to find the value of little a. Wouldn't we say like little a divided by the sine of, what did I use? 40 point something. I already forgot what I used. Oh man, I cleared everything out. There you go. Thank you. 40.5833 is equal to C, which in this case is 700, divided by the sine of 105.15 degrees. So we multiply everything by the sine of 40.5833. That'll cancel this guy out. And so we'll get little a is 700 sine of 40.5833 all over the sine of 105.15. Okay. All right, so let's try this. 700 sine of 40.5833. Let's see, divided by the sine of 105.15. Close that off. So my little a, and it's asking me to round to the nearest foot. So I would say 472. Okay. Okay, that's 472. Okay, and now let's see if we can find the other one. Let's see if we can find the value of little b. Okay, so again, y'all, I'm looking at my picture right here, and I would probably say something like little b over the sine of whatever 34 point. So what do we have? We had 16, so 16 divided by 60 was, yeah, 0.2667. So 34.2667 is equal to the same thing, 700 over the sine of 105.15. So again, we'll multiply by that sine of 34.2667. So this is going to give me b equals 700 sine of 34.2667 over the sine of 105.15. All right, so let me do this over here. Let's clear that out. 700 sine of 34.2667 divided by the sine of 105.15, and I'm coming up with 408. Okay, so let's take a look here. Come back to my picture. So we just found little b to be 408. So what I'm going to do, y'all, I'm going to clean up that mess, and right here, I'm going to say this is 408, and we found little a to be 472. So when I look at part A, it says the distance from A to the helicopter is 408, and the distance from B to the helicopter is 472, right? Okay, so now let me come back to my problem. So this one we had 408. This one we had 472. And let's check it. And all right, we got it. Okay, and now it says, how high is the helicopter from the ground at the moment of elevation or observation, round to the nearest foot. So if I come back to my picture, y'all, what we're trying to figure out now is what's that distance right there, right? What could we use to find that distance? Anybody know? Which trig function could we use? Yeah, we could use the sine, right? We could say the sine of, say, this angle is equal to the opposite of the hypotenuse. So we could say the sine of 34.2667 is equal to the height, we'll call it h, over 472. And so now I'll just multiply everything by 472, and that's going to tell me that h equals 472 times the sine of 34.2667. Right there. And so let's do that. 472 times the sine of 34.2667, and hit enter. And if I'm still going to the nearest foot, I would say 266. Right, so height is 266. And when we come back over here, we'll type in 266. We'll check it, and we got it. Oh, okay. He didn't ask number 10. He said number 10 was how he was feeling. But it's okay. Well, we did number 10 anyway. All right. So, well, in case you were wondering about number 10, now you know how to do it, right? Yeah.
Can you find the equal and triangle to another way to the other side? It's not a vector.
Yeah, you can use the law of cosines, that alternate form of law of cosines. So guys, let me stop